Alright, keep going, and in this lesson I want to show you how to create and apply some forces to our particles. Because for now our liquid is static liquid, there is no any velocity, there's no any movement, and I need to create a little bit of noise. There's two different velocities or two different forces I want to apply to the liquid. It's a little bit of noise to closer to the ship on the water, because we will apply the same waves which we apply to the ocean surface. We will use the same ocean spectrum for creating the geometry for from our flip simulation, but I want to create a little bit more noise near the ship, because the waves should have an interaction with the ship, and that's how it should look. So I create noise, and I will create a little bit of velocities from the explosion. So the water closer to ship body should create some kind of explosion, and the water should move up, create some splashes and all this stuff. So the both forces we will create manually. Before we do this, I want to change my simulation a little bit. The first thing I want to change is go to start frame and set 1. So I want to create an animation from the first frame, and because I need to have a liquid near the ship in the first frame, and I want to apply the noise in the first frame. Also, what I want to do, I want to go to my water source and change the activation just in first frame, because if we set activation 1 for all our frames, it will create particles again and again. It will create some kind of stream, but I don't want to have a stream. I want to generate my particles in the first frame and keep them at the same position. I don't want to create new particles. That's why I want to say that $f equal 1, which means that the activation 1 will be just in the first frame. In a other frame, if we switch to the next frame, you can see it will be 0. So we generate liquids, and the next frame it will keep because of our static geometry, which is like a geometry, the pool geometry. And the next thing I need to do is go into my flip source, and I want to freeze using the time shift node. We have our cache beginning from frame 23 or 24, but we need to have our ship from frame 1 if we want to create simulation from frame 1. So in this case, what I can do is using the time shift to freeze our frame 24. Okay, so if I want to do this, I can go and clamp to first, and except of frame 1, I will set frame 24, which just means that till frame 24, in all this, during all this frame range till frame 24, we're gonna have the same frame 24 from 1 to 24. So it's like create some kind of still frame. So if you select time shift and update, we should see our ship VDB even on frame 16, and it doesn't matter that our cache begin from frame 24 or 23. All right, so it's like a static geometry. Here you go. That's our geo. Sometimes it creates a weird position for camera. So, and now let's create some forces. And the first force I want to apply here is some kind of noise. So if I want to apply the noise, I need to select the volume where I want this noise apply, or the method I want to use. So there is a few different methods how we can control the velocity inside of our simulation. As you know, there is two input with velocity, is particle velocity and the volume velocity. If we want to apply the volume velocity, we need to create some kind of volume and put there the velocity field and set where I want to push my particles using the field. And another way, we can take particles, which is geometry, so we can use any kind of geometry wrangle, geometry warp to apply vectors for our liquid or create velocities. So let's do this. Let's create velocity for our particles. Let's go and create geometry warp. So if we inside of dynamic level, we need to use the geometry warp and add noise, let's call this. So creating velocity noise. And what I want to do, I want to take the noise, create a noise actually. So let's open this in a full frame. And if we want to apply velocity or add velocity to the noise to the velocity, mainly I use the call noise, because as you know, the call noise mainly used for applying noise to velocity. Yeah, it's the same kind of noise if you use the point velocity, let's say. And we're gonna use 4D noise, which just means that we need to put the vector 4 inside of here. You can see we have a yellow input, which means that it expect, you can see here, vector 4. Vector 4 means that to our old vector 3, which is contained from 3 different elements, x, y, and z, we expect 4 elements. And this time is x, y, and z, and time. So if you want to create this vector, we need to convert. We need to add to our position one extra value. And to do this, we can use the vector to vector 4 conversion. So for the first vector, we take a position, because noise should have a position, because we need to know where I want to apply the noise. And in this moment, the time will be applied to control the noise. So the time can be used as an animation factor. It will change our noise during the simulation from time. So it's depend of time, because it's very interesting thing, because if you want to change something inside of this noise, we can use the offset parameter, for example, all right, and we can push our noise in some direction, x, y, or z. But if you want to have animated noise, we can simply use 4 vectors. Sometimes I use the AA, anti-ALZ noise. We can select the 4D input here also, so we can apply a nice noise. But for the velocities, I prefer to use the kernel noise, like in this case. And now we can say that I want to add this noise to existing velocity. So if you take velocity, connect it here, and add my noise over there. So I apply this noise to existing velocity. In this situation, we should have some, changing. And if we apply geometry warps work with geometry, as you can expect, and our particles is geometry. It's not a field, so we don't need to convert this into the field if you want to, have an influence on our liquid simulation, because we connect this to our particle velocity, which is fine. And let's display a few frames to have to see. I want to change something on my noise, because it's empty for now. I mean that I want to take my input parameters over here and change something. Let's increase the amplitude, because amplitude of 1 can create very subtle effect, and we can't maybe we won't see nothing here, because the velocity of 1 can be very small to push our particles and change the velocity. Change the velocity color to see how it works. Wow. So the amplitude 5 is not bad, but what we can see from this angle is, the first thing I can see is that the noise is pretty small. The scale of the noise. So we need to change the frequency. It's looking good, but let's stop it. And let's change the frequency to maybe 0.1 or something like this. So the frequency, the lower frequency setting, the bigger noise we will be, the size of this noise. So let's say 0.15. I'm gonna keep this 1 because I don't want to change the time. Time should be the same, the amplitude of 5. Okay, let's go here to my camera and let's make a play blast, a simple play blast just from frame 1. I just want to see how this noise is changing. And I need to animate this noise because I don't want to have, this noise during all simulation. You can see that it's pretty dramatic. I need to reset simulation because I guess it going from the previous frequency. I don't want to have it. So back there, you can go to the flip sim and reset simulation. And let's create a flipbook again. So I need to animate the noise, and I guess just the first frame 5 or 6, I will apply the noise and then I will turn off this. Maybe I will turn on this noise again somewhere around, I don't know why its frequency, it's still such a small. You definitely should apply less frequency. That's weird. I don't know why it is still very small frequency. Should have 0.15. So maybe create even smaller. Okay, there's too much noise, so let's stop it for the moment. Let's make some changes. The first thing I want to change is maybe the strength, also the frequency. Let's make it smaller, 0.1. And in this case, what I want to do, I want to control the influence of this noise to my how I can say it, to my directions. So if I set a multiply, I want to promote parameter and say vector multiplier, okay, and use as a vector. By default set 1 1 1, so by default 1 will not change nothing. But if I change, I don't want to have too big, you know, no, surface normal, where's my multiplier? Here we go. I don't want to have a big influence to my y-axis, so I don't want to push my particles up. I want to push them on the x and horizontally, x and z axis. And let's animate it. So I can animate the amplitude. So add a keyframe, hold an Alt key, and go somewhere into frame 6 and change the amplitude to 0. Holding Shift button and press H, we can create this kind of curve. And let's look at the result. Back here, press Escape, so it's updating. And now let's look at the result here. I don't want to use a flipbook for now because I want to see, I want to rotate my cache, look from different angles to have an ability. Oh, you can see now this more flat result, as we can say it, flat. There's not too many vectors, up vectors, so it push our liquid in X and Z direction. We can even create a bigger amplitude, I guess, because yeah, we can create a bigger amplitude. But we definitely need to create a little bit bigger, more space here, because we can see the end of this liquid. Also, what I want to do, I want to apply the noise not for all volume. Let's imagine that I want to apply the noise closer to the closer voxel to the ship body, the more noise I want to apply to the liquid. The bigger distance from the ship, the less noise I want to apply. So it's like a non-linear noise, and I can see that my water is falling down. Why has happened? I guess my geometry should be fine. If you unframe, I will stop it. I want to look at my liquid, and you can see that it's falling down. This situation can be caused by geometry, which I put to keep my particles at the one place. So sometimes you have some kind of leaking through the geometry, and we still have a flat surface. So what we can do, we can go to our static object, to our water bound, and just increase the voxel size to like 0.3, I guess. it should help. So the bigger size of the voxel, the bigger width we're gonna have for our geometry. So in this case, if we set 0.3, it will create, we can compare, it was like here. So in 30% we had, well, let's say 50% more width. So now it should keep our particles at one place. Go back here, and okay, with animation, let's set like 6 for this guy, and maybe increase the turbulence a little bit with the roughness. And because I want to have a little bit more detail, small detail, maybe we won't see those details on this resolution because we have not such many particles amount. If you go to information, we can see that we have just a 3.4 million particles. There's a very low amount, really, because the flip simulation, you know, I work with liquid simulation many years. Over 10 years I work with liquid simulation, begin with real flow, and one of the main things liquid is the particles amount, because if we can, you know, apply some tricks for the atmosphere simulation because there is semi-transparent voxels. But in liquid, we don't have a semi-transparent stuff except of the white water. The liquid is geometry in the final. When we convert our particles, it will be a geometry. And the more particles, the more realistic a liquid will be. So if you want to work with liquid, you should have as many RAM as you can and apply as many particles as you can for your CPU or your RAM amount, because it's really depends on the particles amount. All right, and that's why it's very important to, you know, to optimize your source, because if you have too many liquids somewhere away from camera, you know, and you just spend a lot of resources for nothing, it's very important. Okay, so what I wanted to say. Okay, I want to apply this noise depend of the distance to the ship. All right, to ship body. The closer ship, the more noise. The closer, the far away from the ship, the less noise you're gonna have. So, what is the length of this container? If you go to volume, and 18 is height, and the box size. Oh, okay, it's a box size. I don't care about box size for a moment. I want to look at this active zone. So 24. I will make it bigger. So for my tests, I will keep 24, but let's say I will increase the size of this container more. So okay, 24. Let's say let's use 25, just to make it a little bit bigger distance. So let's manage that we have the distance from the ship till the end of this container is 25 meters. Somehow we need to apply this velocity, this noise, which we have here on our geometry warp, depending on the distance to the ship. How we can look at the distance? We have the ship in our simulation, but this ship is the VDB, is volume, right? How we can use our, here we have this surface from our ship to define the distance. In fact, it's very easy because our field here, our volume field, is an SDF. So again, let me draw a little bit. So let's create a new. All right, so let's manage, this is the surface of our ship. This is like a side. All right, we have a water underneath, somewhere here. So the SDS, assigned distance field, again, you can find many information on the internet about that because it's very important for understanding how the thing works. Because, you know, when we create the standard volumes using, let's say, the density, okay, let's manage that we have the voxel. If you want to say that this voxel filled with the smoke or with the density, we just put 1 inside of this voxel. If you want to say that inside of this voxel there is no density, no nothing, it's empty, we can apply 0 density on this voxel. That's very simple. If you want to apply different values, let's say somewhere on the edges of our object, we can apply different type of information, 0.5, 0.3, 0.2, and etc. The less value, the less density we have in this voxel, very simple. But with the geometry is a little bit different situation. When we create the volume, the SDF volume, it means that in each voxel, we're not storing information about how many geometry we have on this voxel. All right, because there is just two options: we have geometry or we don't have a geometry, you know, because it's solid object. It can have like a transparency. We can say that in this voxel we have like 0.5 of geometry. Okay, it is inside of the voxel or not inside of the voxel. Okay, so in this case, is an SDF field show us in the voxel the distance to the geometry. So let's say if we have a voxel inside of geometry, it have a 0. Inside of geometry, I mean in solid objects, let's say, okay? Or, no, I'm not like this. Let's type a little bit. Okay, we don't have it. No. I want to draw this again. Okay, so that's our ship. So we have two areas, inside and outside. So the voxel outside of geometry, they have a positive values, and the value inside of voxel show us the distance. So if we have a value of 10 inside of this voxel, it means that the distance between the geometry and this voxel is 10. Also, we have a negative values, let's say -2, and it shows us that this voxel inside of geometry, and also the distance to the edges of the geometry should be right, should be 2. So we can use this information to define where I have what is distance. So now if I want to apply like a velocity for our liquid, but with some different settings, okay, let's say over here. So for voxels which are closer to geometry, which have a less distance, I will apply my velocity for maximum. I will use a multiplier of 1. For voxels which have a distance bigger than, let's say, 25, as we know, we will apply multiplicator 0, and velocity in this case will be also 0. So what we can do, we can take our SDF field, we can take our volumes which we already have from our ship, and define which voxels have a distance. I mean, what distance have each voxel, and depending on that, we will apply our noise. So how we can do this? If we take our ship, what is it? Okay, I disable template now, and I enable the flat wire shaded. So for now, you can see that what I have, you can see this pink bounding box. This bounding box shows us the science distance field for our ship. So each voxel of this field, of this box, will have an information about distance to our geometry. But if I want to have a bigger box, let's say in this area it should be fine, but on this area I don't have information what distance in this area because there is now this box. We need to expand this box from the ship. So how we can expand this is again very easy. We can go by a few ways. We can go by VDB activate. There is an expand option, but is in voxels, and it's if you want to expand this volume much bigger but keep the same voxel amount, sometimes it will cause very slow calculation because we're going to add more and more voxels. But what if we're going to use the VDB from polygons, and in this case what we can do is just increase the voxel size. It's the first thing I want to do, and because I don't want to have a very heavy calculation, and also I can use this exterior and interior band voxels. What does it mean? It means that we create let's make 0.5 maybe. We can create the expanding. So if we expand this by 25 as we did last time, now you will see that we create a much bigger volume, much bigger volume. Now we have information away from camera, away from the ship. Okay, so now we can use this information, and also, you know, our VDB field will change because we have the flying fragments from our ship. So I want to keep this volume at the same position. So I want to freeze this volume for now, so I can take like frame 24, just for example, and use just one frame. That's very important. So our flying object will not have any influence on the size of this bounding box, because if some fragments will fly on this direction, it will be automatically update this VDB from polygons, and it will shrink our container more and more. I don't want to do this. I want to have just container like this. So let's rename it, and let's call this, I don't know, the water volume. And I'm going to use this water volume to create, some kind of mask for our noise. We can say where I want to put more noise or less. And if I go here and let's go to geometry warp, and I want to copy this null object. Let's copy this, get back to geometry warp, and in inputs, in the second input, you can use the side or force. I select my water volume. I'm going to use now this input to get information from this volume. So if you take information from geometry, it's very easy. We can use in the bind node if we don't have attributes in this list. But if you want to grab some kind of information from the volume, we need to use the volume sample file. Volume sample, and use the sample position here and the file name from the second input. Also, we have the primitive number. In our case, we should have, where is my flip source? If we go here, we have just one primitive, is surface. So if we have a fields, the order of fields should be the order of primitive. So yes, if our surface field in the first position, it have a primitive number 0. If we have like two fields, like we had here, we have a surface and somewhere around frame 25, we have a surface and surface velocity. We're going to have a surface on the first position, it will be a primitive number 0, and surface velocity will have a primitive number 1. So now what I want to do, now I have the value, it's a distance. I'm going to use the fit range for setting the distance. So as we say, the minimum value, let's say it should be like 2 meters from the surface, and the source max should be 25 meters. And we invert our output. What does it mean? It means that here we have some kind of multiplicator for objects, or in our case for particles, which will be closer to our ship surface, closer than 2 meters, 2 or small or less. They will have 1 as a multiplicator. So if we multiply, use this multiplier, use this float value as a multiplier, all particles which have a distance closer to 2, they will have 2 or less, they will have a multiplier of 1. So the noise we create here will be applied in 100% for them. For particles which have a distance to our ship 25 meters or more, they will have a multiplier of 0, and the noise won't be applied for those particles. And as you know, particles between 2 and 25 will have a multiplicator between 0 and 1. So the closer you to the ship, the more noise you will get. It's very simple. Let's see, does it work or not? To do this, again, I choose my anim cam, and we can play with this, and we will see the difference for the noise depending on the distance. Maybe I set a pause to calculate a few frames. Even on second frame, we can see a difference, that on this area we have much less noise than in this area. We definitely should shrink this a little bit, because you can see that our ship is on this area, it will be closer to the end of the box, and that's why we have a more noise here and less noise here. All right, that's fine. That's fine. We have a noise and we have a ramp like here. Maybe I can use a ramp a little bit to control how many noise I want to apply. closer to ship or far away from here. But we still have some leaking. You can see that my water is going down, and the main reason is why it's happening is not because of our static object geometry. The main reason because of the flip object, because I forget to close boundaries here. Why I need to close this? Because if you go to our flip solver and if we back to to the volume motion and to our volume limits, we can see that our bottom limit, if you look at the say it from the right viewport, you can see that our lower limit for our box is under the water. So if we enable geometry, display our geometry, collision geometry, you can see that our geometry below the bottom container limit. And the thing is, our particles will, our container delete particles when they hit the bottom limit, and they can't go to the collision geometry, because in this case collision geometry is outside of the collision box, it's underneath. So to make it properly, I go to flip object and press closed boundaries. I just disable plus Y because I want to move my liquid maybe up without any collisions. So now what I do, so what is the difference between this? Now my collision geometry will save my liquid particles just on those boundaries, but they won't go down. In this case, I prefer to use the limit for our container, except of the geometry. And the main reason because the geometry is always some information, it's volumes, it's big voxels, which we need to put into the RAM to make a collision. So for our boundaries from our container, they like a free collision. So we don't need to spend some RAM to load this geometry. So in this case, I will leave my geometry to have these boundaries on the side of the liquid. But for my bottom boundary, for my bottom limit, I want to use my container. That's why I'm press here, closed boundaries. All right, and it should work fine. And always you need to keep in mind that your container by default will kill your particles if they fly away through the sides of the container. All right, so the next thing I want to create is a force from the explosion. And mainly I want to use this force from the ship body, because I want to move my liquid along the ship surface. To do this, I go to the ship animation. That's why I leave this node here for our liquid. And I already have some preparation, so I want to remove this for a moment. I want to remove those objects. All right, we will do this from scratch. So what we have is our deformation, which we had in fact from our RBD simulation. Let's just wait a little bit because it's need to be updated to look at geometry. So this is our ship. This is our ship, and there is no trail, so we'll just test. The thing is, what we need to do, I want to take this geometry and create some vectors along this body surface, and I want to add a noise and apply those vectors like a force for my liquid, which will be near this ship surface. So to do this, I need to, well, the first thing I need to do is select just this side of the ship. I don't care about all other elements which are far away from the water surface. So to do this, I can use the select group of connected primitives, and I'm going to use the shop material path. So I select, get this element and delete, and then delete non-selected. That's why I have just this bottom area. And I'm interested in just to, with the right side, I don't care about these elements here. So we can do again, select, primitives, but not with this guy. Just maybe go to a simple flat shaded. Let's select this area, the left side of the ship, maybe like here, and remove it. Cool. So I need to put this guy here because I still have this node, and then I create a new node. Then set the attribute triangle, and with this attribute triangle I want to remove all primitives which will be, or points which will be lower than some threshold. So if position by y-axis with a capital P will be less than, let's say, -1, then I want to remove points from fast input by pt num, by the point number. So now we can connect it here to this blast, and that's what we have. We have like a line from our ship body, and we can use this line for creating velocities along the surface. So let's create a scatter node. Let's make like 10,000 points. Oops, 10,000 I said. And I'm gonna use those points to create the vectors. I can work with the normals, which are perpendicular now to the surface. So let's add another one. Set up a vector. I can call this like this. So the up vector will be equal, let's set it to a vertical vector, maybe like 0.50. Now let's take my normals and add this up vector to my normals. So now you can see that they going up, but not like vertically. They going along the surface. You can see in a different direction. All right. And then let's add some noise because they all have the same lengths. But with the force, I definitely need to have some noise. So with the attribute warp, we can add, let's call that noise just simply. Oops, add noise. Go down inside, and we will create a very simple kind of noise. Let's set a turbulent noise. I want to use the feed range because I want to control the amount of the noise and multiply. So I'm going to take my normals and put it back to normals. Take a position for my noise. I can create the input parameters for the noise, connect it here to value, and go to the multiplier. So why I want to use the feed range? Because I want to take all values between -1 and 1 and go to 0.1 and 1. Why I use a 0.1? I don't want to have a 0, so I don't want to remove my normals completely. I want to have some velocities, even if they will be small. I want to still have those velocities. So now if you look on them, they have a different size. Not too much, so I need to play with the noise. First thing I want to choose changes. I choose the sparse convolution noise. And let's increase the frequency a little bit, maybe like 222, and I want to increase the amplitude to have a bigger difference between the smallest and the biggest values. So now you can see that some areas have a very low noise, very low length of the vector. Some points have a bigger length. And now let's convert those vectors to velocities because I want to use a velocity. It will be equal to normals. Okay, and then let's say we can create a density. Maybe it can help at some stage. Let's create not a V, let's create a val attribute. Val, and it will be equal to a normals, and create the volume rasterize attribute. Use density, val, we convert val into the velocity. So basically we create the field, the velocity field, maybe use a bigger voxel size. And I'm going to use this velocity field to push my particles up. All right, so We already have ability to apply velocity. Let's switch to manual mode for the moment. To apply velocities using the geometry op, and we can apply this using the geometry, our particles. In this case, we can use the volumetric using the fluid. So we can convert this into VDB if you want to. And say the null object, it should be the body velocity. So body vel, make them black, and let's copy it. Okay, I need to change here nothing. I'll leave it. Go to flip sim, and I will create another volume source because we applied the volume velocity. Let's add the merge. I want to combine my ship surface, and in this volume source, I want to add my val field, which I just created. So I copy here my body val path, where I want to take my information, and I select the vector. So I take a val and apply it to val. So val to velocity. All right. So I take my source velocity, and to target field, it should be the same val. Let's call this body val. And what I want to do, you can see that this velocity doesn't connect to any explosion frames. Yeah, we can do this. We can take our explosion info, we can take our explosion animation, take our attribute explosion frame, transfer this attribute to our points. We can do this. We can do this. But in fact, in this case, I can do this manually. I don't know, maybe if I have many different elements, many different objects, many explosions, I can play with this. In our case, we have just a few big explosions. One explosion frame 25 and some multiple explosions around frame 48. So what I want to do, I want to just animate the velocity for my explosions. So we can go here to our body val and make a very simple stuff. I can say that I want to activate this force just on frame 25 or on frame, let's say 48, just in one frame. Frame equal 48. Okay, and those frames I will apply my velocity. And also in the first explosion, let's say I want to leave the scale as 1, and let's go to frame 48, and I increase this scale to 2. So I will create a bigger influence from this velocities. Okay, so that's how it should work. And I don't care about curve because between those points, because I'm gonna use just those points. So it doesn't matter what curve between them. And it should work. Let me check the last time is right here. All these things here, good, gravity, our static object. All right, so what I want to do, I want to cache this simulation. So to do this, I'm going to use the DOP import fields. And the fields, because we're going to use the fields and particles. So if you go to our DOP network, let's select our flip sim is our DOP network. And let's select flip sim, flip object. So we can type flip obj and start in case we have multiple objects there, and select the flip fluid. With the flip fluid, it will automatically add some it's not a field because we have a well, it's field, but it's field geometry. So we grab our particles, we grab our surface, and also we have velocity, so we can grab this velocity. And before I go into the file cache, I want to compress my fluid. In this situation, we can not doing this, but mostly with the liquid simulation, we need to compress the fluid for some reasons. Let's imagine that this is our water surface. I'm sorry. This is our water surface. I don't need to select nothing. I just want to draw. All right, this is our water surface. And we have some depth here. So we have like a water volume. It's a big water volume. And we have a lot of particles in here. In our case, we have just a few meters depth, so it's not too big. But in some cases, when we create a liquid volume, we create a pool of water, the amount of particles are pretty big. And in fact, when we save this information or store this information, we don't care about particles on this area because they're somewhere under the water. We don't need to use a velocity. Mainly, we're gonna use particles on the surface because we're gonna use those particles to create the mesh, and then we will use this mesh to render. All right, so when we save information, we don't need to store all our like dozens, million particles. We can define the depths for our calculation. We can say that, okay, let's take our surface position and let's store some particles closer to water surface as a particles. And all other volumes we're gonna save as volume, like solid volume, like a solid object. So that's what fluid compress doing. So it's very simple node. You can see that we have the particle separation and it should be the same size as we have in our simulation. So let's copy this. Copy parameter, let's back to flip cache and let's go to fluid compress and paste relative reference. So we're gonna have the same particle separation and we have the call bandwidth. So the bandwidth, as you can see, if any particles below this depth in the surface field will be deleted. This parameter is specified in units of particle separation, so it's the same thing I show you over here, the depths for our particles. So all particles below depth of 4 will be converted into the volume, all right? So when I press fluid compress here, and let's go to first frame and enable auto update. Let's look at this. I hope it should be fine. Go to my flip sim. Yeah, here's my particles. And where is my particles here? Let me choose flip sim. Oh, I don't need the path, sorry. If I want to use a path, I need to go here on the dot node, but all right, so here's my particles. Here's my particles in the DOP import field, and that's how we can look in using the fluid compress. It's not visually very good. We can't see particles anymore. You can see they're just a bunch of boxes. So that's how it's stored information. That's how it's stored inside of the file cache. So let's call it flip. And I want to send it to my X drive. Houdini. Ship explosion, and let's rename this, delete this. All right, so I begin my saving from the first frame, and yeah, if you want to, let's say, look at this information, and after you save this thing, you want to look at the simulation result, you want to look at the particles, we can use the fluid surface, particle fluid surface node. This particle fluid surface allows us to visualize many different elements. We can visualize particles in compressed fluid surface. We can create a surface polygon. That's where we're going to use a particle fluid surface also. So if I type particles, press particles here, again, I want to paste relative reference to my particle separation. It should be, again, the same for correct representation. So now you can see that my particles are back here. And also using the different types convert to, we can use the particle and compressed fluid surface, compressed fluid surface, also the surface VDB or the surface polygons. So based on our particles, we can create the polygons, actually create the mesh, which and we can render out this mesh. It takes some time for getting. And the reason why it's important to enable your particle separation here the same size as your simulation particle separation, because when we create a surface polygon, basically the method how we create a surface polygon is almost the same as it's used many years ago and it's used in many programs. We create some kind of spheres around each particle or metaballs, and we connect those spheres between the closest particles, and using the particle separation we can define the radius of the sphere. So if we make this particle separation bigger. Let's say we can do this plus, I don't know, 0.5, let's say. So that's how our particle separation will be 0.65. You can see that our mesh is a little bit wrong. We have less primitives, and the reason why we have less primitives because depending on the particle separation and the particles amount, we're gonna have the quality of the mesh. So the more particles, the more primitives we're gonna have as a result, and we're gonna have a bigger quality. So it's some kind of automatic stuff. So the more particles, the more primitives we're gonna have, and also we have more details for this stuff. For now, you can see this flat surface, and we will display this surface using the same material as we did with the ocean spectrum. So I don't care about the flatness of the water. Yeah, it's just the first frame, so it's flat without any kind of noise, without any velocity influence like we did. So what I want to do now, I want to cache my simulation and try to make a few different types of simulation. Well, I want to definitely shrink this thing here on this side because it's very it doesn't have a very wide simulation because our ship is going like here, and we don't have a big gap between the closest ship surface and the end of our container. Yeah, I want to optimize it, but also I want to cover the more region I can. So I will shrink it in this side, in this direction. And also, I want to show you a few different simulation types. One simulation is noise with our velocities from the explosion, and another simulation is just the velocity without noise. So you can see a difference. And we're back after a night of the sim. So I created two different simulations. So in the left side, you can see the noise. I animate the noise for the liquid in the first frame and also on frame 25 and frame 48. So you can see there is a lot of noise, there's a lot of splashes. And yeah, you can use this type of simulation. It's more like kind of splashy. And we have like more influence from the explosion in this area. You can see that on the right side of our container is almost flat. So it's almost the same like we had in the beginning. There's not too many noise, there's not too many explosion vectors. But so we can definitely use this simulation to create more splashy, more noisy results if you want to have more action in the water. And here's another way is if I turn off the noise from the waves, you can see that, well, the next explosion, the second explosion is not bad, but the first one is pretty flat. You can see it very, very flat here on this area. The another one is much better. You can see the noise, how we applied the noise to our vectors. But also you need to keep in mind that it's very low res. Well, it's not very low, but it's 0.1. And I get that for the final sim, I should use some kind of 0.75, 0.5 maybe, if it will be enough RAM for do this. So optimize as much as I can. You can see that I shrink this thing here, our container, make it more wider, and it's looking like this. So I like this result, but I get this our waves is too big because really I forget to put my ship here to see the difference, but need to keep in mind that this is like a height of the ship, of our deck areas of those waves really too big, because it looks like the explosions in the water surface and not inside of the ship. So why I'm doing the both simulations. So now you can choose the way you go. You can go by this way, you can go by this way. And in fact, in my preview, I use just this simulation with a little bit of noise, so not such a dramatic, noise here. So with a less amplitude, not such here, so we can see just a tiny bit of movement on the surface. And that's how we apply for our final simulation. Keep those vectors, but add a little bit of noise on this surface. Again, we will add waves using the texture and using our shader, but I want to add a little bit more extra moving around the ship using our noise, but not such a big. Anyway, and sometimes, let's say if our ship is moving and if our explosion is very close to water surface, you can apply this thing here. Also, I can apply a little bit of drag because, you know, we can keep our particles more closer to the water surface and using the drag in our simulation. All right, that's how we can do. So let's back to our sim and let's finalize our flip simulation before we go into the whitewater surface. Whitewater creation. So if you back to our simulation, you can see that this is the version without the noise, and if I type 01, as I said, I make different simulation. Let's go to auto update. You will see the different sim with a little bit different of point location. Here's the noise, and if you want to visualize the velocity, it's very useful stuff because I want to see the maximum velocity and the minimum to understand how big velocity it is and what I want to change here. So you can see that from one side, our velocity is our noise for the water surface applies a nice noise for our velocity from the ship. So if you compare this result with this, this is very flat. It's very flat, and yeah, we can make this area a little bit smaller because it can be a little bit wider than I expect. So if you go here to volume rasterized attributes, we can make it more in detail. So we can add a 0.4 for the voxel size, and also we can set up the particle scale like 0.75 and it make it a little bit thinner for this area. It won't have influence for now because this is pre-cached element. So the velocity is very useful if you want to look at the maximum velocity. If you want to create some kind of the drag option, or you can cut velocities at some area, at some threshold, you want to know the biggest velocities. So here we have the velocity range by default from 0 to 10. So you can see there is not too many white areas. If you go to frame 48, there should be the areas with the velocity bigger than 10, and you can see that now we have some white areas. With the noise to the surface, it will be even more bigger. So you can see a nice like bang, like splash from the explosion. You can see the wave going out of this. So I like this version, but I don't like the very flat surface over here, so I can leave my noise but not such intense. So, but if you really want to have so how you apply the velocity range here, you can see that just the float values. If you go down inside of the particle fluid surface, you can see that we have the attribute warp called with vel. We have the with vorticity and with velocity. And if you dive inside, it's a very simple warp. We take a length from our velocity input. We use the fit node, which is create the range from 0 to 10. Also, we can apply the ramp and put it into the CD. So the ramp is applying the color. If you select like bluish tint to the yellow to the white one, so it's very simple method. You can do this by yourself, or you can simply using the attribute triangle, because we already have the velocity. You see that we have the IDs, we have the droplets attribute, we have the color applied using the velocity, and also we have the velocity itself. So if you go to attribute triangle and say that let's go and create some test attribute, which will be equal to the length of our velocity field, velocity attribute in this case, because it was just particle. Here our test. So let's look at the maximum. So the maximum value is 25, a little bit more than 25, 25.7. And this is on frame 51 where I have the biggest influence because I have a bigger velocity from my explosion and also with noise. So we can say that, okay, maybe I want to cut all those elements which have velocity more than 25, just as the option. I don't want to do this in this case because I really want to have this nice wave from the explosion, but you can do this if you want. So if you see that sometimes our particles just fly away with a big speed, you can create some kind of cut cat wrangle, for example, the pop wrangle here, you can type that if our velocity using the fit node or fit command, if our velocity bigger than 25, you can, make a reverse multiplicator, multiply by 1 from 0. And anyway, I mean that you can type a very simple, pop wrangle, and just in situation if you want to reduce the velocity, you can set a multiplicator and set that using the fit node, if our the length for velocity, let's imagine that we have the length bigger than 25. We want to cut this, let's 25 to like 50. Then use one point, let's say 0.5 or 0.75. So it's meaning each time when we see the speed bigger than 25, let's say from inch 50, so all values which have the speed of 50 or more will have multiplication 0.75. This means that they will lose 25% of the speed in each substep. All right, and those values which have a speed 25 or less, they will keep the same velocity because we multiply them by 1. So in this case, you can create some kind of speed threshold. Speed threshold. Okay, and you can apply it to our jump to warp, and I mean that it will go through this line and go inside of the particle velocity. So anyway, we can do this. In this situation, for us, it won't have too many effect because we don't have too many particles with a speed bigger than 50 or even bigger than 25, because 25.7 is the maximum for now. But anyway, you can make a different types of explosion. You can make different types of simulation. So we can do this. All right. So with the noise, what I want to do, if you go to amplitude, you can see that I have in the beginning I have a 6 and 0 in frame 6 again. So we have like a nice curve over there. So what I want to do, I want to reduce this amount to like 3. I want to have a very slightly effect from my noise. So 3 should be fine. I'm in manual mode, so you can see that we have 3 till frame 4, and then we begin to lose the energy and my amplitude fall down till this. All right, so that's what we have at this moment. Also, let's increase the frequency a bit. So 0.1 and 7, let's say 0.175, okay? So I don't want to, our frequency is very, maybe like so 0.15, let's say. Okay, 0.50 should be good. All right, so the roughness is 0.65. We can do a little bit smaller, maybe to 55. Okay, vector multiplier 0.75 to make even less influence on Y direction for the noise. And actually that's it. Let me look at the flip solver here more closely. I guess that I can leave all those settings as I have here. Yeah, 2 substeps, looking good. Maybe decrease to 1. Okay, that's fine. So I want to make this area bigger. I mean that I create this simulation on another computer and I change the width of my container there, but I don't change it over here. So if we go back to our flip source, this is our flip source. Let's update it, and you can see it's a little bit small. So let's go to the active zone and let's here the size by Z, let's say 35. And in this way, let's go to auto update. It will be much bigger, so I want to move it like 7 to, let's enable the ship. I want to look at, yeah, looks fine. Yeah, good. If I will move even more on Z, you can see that we lose some elements near the ship. I don't want to lose it. Go to anim cam. Yeah, it's all fine. All right, so the active zone is here, and I make it bigger, and all this will automatically update. And if you go to flip source now, you will see that our particles now exist in a bigger area. And how many particles do I have with the particle separation point 15? Just 3.5 million particles. That's not too much, really not too much, because again, if you want to create a nice simulation for a liquid, you need to use as many particles as you can, even with a low scale simulation. So let's disable this for Wiz. I don't want to look at that. Okay, so let's try to make another sim. And go to flip object, and let's reduce the particle simulation to 0.1 or even 0.75, because I really want to have a nice res for the final look. Oh, sorry, 0.075, sure. Because 0.75, that's too much for the separation. So there was a question on a chat on a Skype for one of our students, why you change the particle separation and you're not changing the particle radius, because it depends. And the reason, because it's a scale. It's not like a static size. So in some programs like RealFlow, in 3ds Max, we have an ability to change the distance between particles, and also the radius of I don't know, like a radius for the forces they will push particle one from another. So sometimes if you want to have more particles but you apply a very small radius, those particles will create less volume. In the beginning, the volume will be the same like in source, but the particle will move down because the radius will be smaller than the separation. But in this case, it's a scale. It means that if I scale down the particle separation, or I make it much smaller, the radius scale will much smaller also, because it's applied the scale. It's applied this like a multiplicator to the radius scale. To the particle separation, sorry. So again, the same stuff with the grid scale. Again, it's a scale, and if you so the particle separation is like a main option. You change the resolution for all simulation, and from the particle separation, all other scales will be less also. All right. So you need to keep in mind that with the particle separation, we're not just reducing the length, the distance between particles, we also make all other elements different, because we apply the scale to this option or to this parameter. All right, let's back here, go to flip cache, and let's store this. We can store like a separate, maybe flip version 2, just to to look at the difference. If you have enough space on a disk, you can simply just create a few different caches and try to find the best option, the best cache, the best simulation. And we store with the simulation only information we need for rendering, for creating water surface, for creating white water and all other stuff. So if you want to make something based on the sim, all information we have inside, because we have n geometry, which is a particle, and the surface, which is the volumetric field, and velocity is volume again. So or I guess starting in particle if you use the particle fluid surface. Okay, and we're going to talk about particle fluid surface a little bit later more closely, because we have also the filtering. We can apply different regions if you want to cut some areas from the creating the water surface. So let's apply our new settings, and let's look at our simulation, how it's looking.